we know that the integral of e to the x is just e to the x, right? What about the integral of 3 to the x? Before we do it, let's talk just a second about what the derivative of 3 to the x was. I don't know if you remember, but when we had y equals 3 to the x, and we wanted to find the derivative,
Natural log of x.
it's natural log of 3 times 3 to the x. Okay? So whenever you have something that's not e, like if it's a 3 or a 2 or a 5, something to a power like that, with the derivative, you multiply by the natural log of whatever that number was. See, with e to the x, the reason that works out is because natural log of e is 1. So that's the reason we don't even use that part of it when we have e to the x. Okay? But if it's another number, you have to multiply by that natural log of 3. Well, when you do the antiderivative, that natural log of 3 or whatever is still there, but you have to divide it instead of multiply it. Because when you're doing the antiderivative, you're going backwards, so you got to make it go away. So the antiderivative is 3 to the x over natural log of 3. Or you can write it as 1 over natural log of 3 if you want to, whichever way makes more sense. So the rule is if you have a to the x, that the antiderivative would be a to the x over natural log of a. Or 1 over natural log of a times a to the x, whichever way makes more sense to you. So looking at problems similar to those, but that also involve u substitution. Let's say we had 2 to the negative 3x, and we wanted to find the antiderivative. So we do like we have been on all the others, it's just combining the rules. We let our u be negative 3x. du becomes negative 3. So what do you do with that negative 3? Okay. Now, be really careful. When you multiply something by something to a power, you do not multiply the 3 and the 2 together. Be careful with that. It just stays. Okay. So we get negative 1/3 integral 2 to the u. So what's the antiderivative of 2 to the u?
U plus 1.
2 to the u over natural log of 2. What about this one? Okay, another problem that involves something to a power. We do have to let u be something. If I just let u be the power, I'm going to get a negative 1, but that's really not going to help me solve the problem because I'm still going to have a bunch of 4 to the x's or 4 to the u's or whatever. Okay? So what else could u be if I don't just let it be the power? Yeah, just like we did on that e one, let it be the bottom. So it's either going to be the bottom or the power most of the time. So what's du? Okay, think about the derivative here.
Natural log of 4 times 4 to the negative.
Natural log of 4 times 4 to the negative x
Times negative 1.
times negative 1 because of the derivative of the power. Questions about du? I know it's ugly.
Wait, where did the negative 1 come from?
The derivative of the power is negative 1, so you have to multiply by negative 1.
So you add by the natural log of 4?
So, on the inside, I need a negative natural log of 4. Natural log of 4 is a number, so it's okay for me to just put that in. If I put in a negative natural log of 4, okay? So then, now my problem is rewritten like this. And now what's the antiderivative of 1 over u?
They just missed times that I go through, okay? It's gonna get worse from here on.
Okay, so here's another problem. 5 to the sine of x times cosine of x. So what would we let u be? And so du is cosine, which is there. Nothing strange about it. I don't have to put in any numbers. So this is just the integral of 5 to the u. Okay, and then what's the antiderivative of 5 to the u? So it's actually 5 to the u, which is sine of x,
Over ln.
over natural log of 5. When you do the antiderivative, you divide by the natural log of whatever instead of multiply.
Oh, no, it's already.
Okay, so what about this problem? Do we have to do u substitution on this one? No, there's no u substitution on this one. So what's the antiderivative of x squared?
X to the third. Oh, heck yeah. Look at me go.
And then what's the antiderivative of 10 to the x?
10x over 9.
Good. So I just gave you that one just to kind of get your rules straight. Remember the first one, use the power rule because the power is the number. The second one is this exponential rule because the exponent or the power is a letter or a variable.